Okay, so hello to anybody watching. This is going to be hopefully a pretty quick video breaking down something that I wanted to do in an SI session, but I lost my notes on it after I did it, but then I found them again. And we're obviously moving past this section, so I'm not going to bring them up in session again. So I'm just going to make this video to talk about this, which is the cosine of A plus B. And the thing that I did is I went off of the sine of A plus B, and I used that to derive the formula for the cosine of A plus B. And the way that I did that is I used these four rules that I wrote down. I used the Pythagorean identities. I used the additive rules that we know. The one that we're assuming to be true is the sine of A plus B. I used foiling and other factoring tricks, and I used a quick U sub. This one is mostly just for me to visualize what I'm doing and not make any dumb mistakes. So this is going to be kind of a verification, sort of. I'm trying to prove this right here. So you would logically think that, well, I need to, like, if we're doing a actual verification, I would need to go from here, and I would need to somehow use some sort of tricks to eventually turn it into cosine of A plus B. But we can't really do that because the rule isn't algebraic. It's something that we just kind of know to be true. So I need a different basis to verify off of, because this I can't work with algebraically or with any of our trig functions or anything. So instead, I'm going to verify this. Cosine of A plus B is equal to a very long, very complicated looking expression. There's another polynomial. That's the word I was trying to think of. Okay, and it looks like this. Cosine squared of A times the cosine squared of B minus 2 sine of A, sine of B, cosine of A, cosine of B, plus the sine squared of A, sine squared of B. And you look at that complicated thing, and it's like, oh, wow, okay, how the heck are we going to get there? And I want to use the sine of A plus B as my basis. Well, here's how we're going to do it. We know for a fact that sine squared of x plus the cosine squared of x equals 1. This is a fact. We know this to be absolutely true. And then we can just rearrange this by moving that over there, and we get the cosine squared of x equals 1 minus the sine of x. Well, now I'm going to declare that x equals A plus B. So the cosine squared A plus B is equal to 1 minus the sine squared of A plus B. So that's our Pythagorean identity down. But we're actually going to use, I think, 2 more later down the line. But we'll get there when we get there. 3 more, actually. So now we're going to use our known additive rule of sine. So here we go. Cosine squared of A plus B equals, and I'm going to just draw an arrow all the way down. I'm not going to keep rewriting this. So 1 minus, I know for a fact that the sine of A plus B is equal to the sine of A, the cosine of B times the cosine of A times the sine of B. So I'm going to instead rewrite it in that form. So the sine of A, cosine of B, plus the cosine of A, sine of B, squared. Now I'm going to factor this whole thing out. So I'm going to get something pretty complicated here. Sine of A squared, cosine of B squared, plus, ooh, I almost forgot. This is very, very important. You notice how there are these parentheses here. That is super, super important that we keep, sorry, I've just got an email, that I keep this entire term together. So I need to put parentheses here. We are solving out this entire thing before we do anything else, because we need to distribute out this negative eventually. Very, very careful that we know where our negatives are going. So the sine squared of A times the cosine squared of B plus, And this is going to be the weird thing. You can just trust me on this because I've done a couple of practice runs of this just to make sure I would get it right. But what you're going to end up getting for this middle term is 2 times the sine of A, the sine of B, cosine of A, cosine of B. Plus, and kind of what we did for this one, we're multiplying 2 of these directly together or multiplying 2 of these directly together. So we get some squares. So these ones are also going to square, the cosine squared of A and the cosine squared of B in parentheses. Okay, so now we have this. This does not look better, does it? But trust me on this, we're getting somewhere good with it. So for this first term, I don't like that I have a sine of A and a cosine of B. I would rather that I have the cosine of A and the cosine of B, or the sine of A and the sine of B. It actually doesn't matter, but for the sake of it looking nicer by the end of it, I'm going to decide that I want to get rid of the sine here and the cosine here. So I'm going to use another couple of Pythagorean identity uses. So this is going to be the cosine squared of B. I'm going to replace this with 1 minus the cosine squared of A. Plus 2, I'm going to switch colors for this. This whole thing right here, this is going to be my U sub. I'm going to use the letter U to replace it. And I'll even mark it with green so that we know that that's what we're doing. This is not necessary. This is just to shorten the expression so it's not so insanely long. The same thing here. I'm going to replace that cosine. So the sine squared of B, 1 minus the sine squared of A. Now we're going to factor that out. I'm going to get the cosine squared of B minus cosine squared of A, the cosine squared of B, plus 2u. That didn't change at all. Plus the sine squared of B minus the sine squared of A, the sine squared of B. Okay, so now all that factoring is done. So there's one more thing that I want to do before I distribute this negative and start to put together the final thing. And I've noticed that I have a positive square root of B here. And I have a positive sine squared of B here. So I'm going to move those together up here in the front. So I'm going to have the sine squared of B plus the cosine squared of B. And for you astute people, you might already know what I'm about to do with that. Sine squared of B plus 2u minus the sine squared of A, sine squared of B. Okay, so this right here, I'll put it in orange. That's a Pythagorean identity. That's equal to 1. You can replace the b with x, the sine squared of x plus the cosine squared of x. We know for a fact that that's 1. Well, actually, we don't want to use x because I used x before. We'll use z. But it doesn't matter. Any variable inside, so long as it's the same variable, it's going to equal 1. So I'm going to replace this with 1, kind of like this. And now we're going to distribute that negative. So we get the 1 minus 1, 2 negatives, plus cosine squared of A, cosine squared of B, plus 2. And since I can do one more step with this u. Plus the sine squared of A and the sine squared of B. And I realized I almost just made a very bad mistake. That negative gets distributed into this plus, it becomes a negative. So 1 minus 1, that's going to disappear. And now I'm going to replace this with the original right here. So we're going to get the cosine squared of A, the cosine squared of B, minus 2 sine of A, sine of B, cosine of A, cosine of b plus the sine squared of a, sine squared of b equals cosine squared of a plus b. And there's our verification. But we're not done yet, because now that we have verified the equality of this expression, we can now use our rules of equality, which means that we can now do the same thing to both sides and we get the same expression. So we're going to do some reverse factoring here. And this is a very hard step, because I honestly wouldn't expect you to look at this and think, oh yeah, that's factorable, because we'll look at it. It's pretty ridiculous. But I assure you that what I am about to replace it with is exactly the same. Cosine of A, cosine of B, minus the sine of A, sine of B squared. If you don't believe me, remember way back here when I factored this out and I got this? Well, we can do the same thing here. So if I would get two of these. So the cosine of A and the cosine of B multiplied by itself, we're going to get this term. The sine of A times sine of B times itself, we're going to get this term. And it does have a negative on it, but a negative times a negative is a positive, so it's going to end up being positive. So then the last term in the middle is, because none of these are going to combine, I'm going to get negative sine of A, sine of B times cosine of A, cosine of B. I'm going to get that twice. So I'm going to get minus 2 sine of A, sine of B, cosine of A, cosine of B. So believe me, that is a perfectly valid factoring. Okay, so now the last thing is we just square root both sides. These squares go away, and there we are. The cosine of A plus B is equal to cosine of A, cosine of B, minus the sine of A times the sine of B. There we have it. So writing back up here, I used all these tricks. I used this one multiple times, and I have verified. Well, first I verified that I would be able to get this expression. And the reason that I wanted this expression, as you saw after, was because I wanted to factor it out. Now that I knew that it was equal, to then get the cosine of A plus B. This is definitely some more advanced usage of verifications, which then kind of became sort of a proof in mathematics. But more than this, the takeaway is the fact that I was able to algebraically prove, I don't want to say prove, I was able to algebraically derive the formula for A plus B cosine. So that'll be all. And if you actually bothered to watch this, thank you for watching it. And whenever you see this, it might be Friday, it might be over the weekend, it might be 2 weeks from now. So I will see you whenever.